Good afternoon, students. Today we are going to see the Fourier series. Fourier series is a periodic function and satisfies the Dirichlet conditions that can be presented by an infinite series called Fourier series. Nothing but, see, for a Fourier series, that function f of should be periodic and also it should satisfy the Dirichlet's conditions. So before that, it is a series called an infinite series. First, you have to know what is a Dirichlet's conditions, and also before that, we are going to see what are the infinite series given here. F of x equal to a naught by 2 plus a1 into cos x etc. up to cos nx plus b1 sin x plus b2 etc. up to bn sin x. Shortly, we can write this as that a naught by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. How we are writing this? See, since we are having an elaborated series like this, we can shrink that series as a common value like this, summation n equal to 1 to infinity an cos nx. So same summation will be applied for the bn sin x also. So commonly they have written this value. So this is the Fourier series, and in this case we'll have the Fourier coefficient as a naught an and bn here. So these are the coefficients. We are going to see the formula for this series for this coefficients also. And before that, I've already told the Fourier series should be periodic and it should satisfy the Dirichlet conditions. So what is a Dirichlet condition here? That f of x is a single valued function. Single valued means that there is only one x variable, that is called as a single valued function with a period minus pi to pi. This is the first condition given here. So within that minus pi to pi interval only, we have to take the values and you have to substitute in the f of x value. The second condition, f of x is a periodic with period 2 pi. And f of x and f dash of x are piecewise continuous in minus pi to pi. That is, see, the second condition is f of x periodic with a period 2 pi, and the third condition is if you are taking f of x, we have the function as like say sin x means when you are differentiating f dash of x, we'll get cos x. So both the values when you are applying a limit points in between the minus pi to pi, we'll get the same answer. So that is called as here as the piecewise continuous. So and then the series is converges to, they have given 2 points. One is f of x is continuity to a point that is given in the first case. This series will converges to x. Then if x is a point of continuity, if you're having it as a discontinuity, you'll have the formula like this: f of x plus 0 plus f of x minus 0 divided by 2. Then now we see the Euler's formula, which is defining the Fourier coefficients a naught, an and bn, which is generally given as the interval like c to c plus 2 pi. Instead of c, we apply first corollary equal in c is equal to 0 we are giving here. If we are giving c equal to 0, we'll get that limit points as 0 to 2 pi in the interval. So a naught equal to 1 by pi into the integral 0 to 2 pi f of x dx we are getting, and then an is equal to 1 by pi into 0 to 2 pi f of x into cos nx has been given here. Why I am specifying this value? It will be changed in another change of interval. So for that I am specifying that is f of x into cos nx, and then bnx equal to 1 by pi into integral 0 to 2l f of x sin x dx. So see the next corollary. If you are applying c equal to minus pi, we'll get the interval as that 1 by pi will be as it is, but the interval has been changed as minus pi to pi, but the functions are the same here. But in the next case, before going to the change of interval, there is a node point, that is cos n pi. It is a general value cos n pi equal to minus 1 to the power of n, where n is a positive integer, and also sin n pi equal to 0, where n is an integer. So we keep that remaining these two values is very important. Wherever you are solving the problem, you have to apply these two conditions, then only you can able to get the solution of the problem. So these are the key points. And then change of interval. Now if you are having the interval as c to c plus 2l, wherever you are having pi values, they are already seen the formula. Wherever you are having the pi value, there you can apply L. So in that case, a naught equal to 1 pi will be there in the first case. And now we are seeing an L value. So instead of that, 1 by L into integral 0 to 2L. So this is the limit point for the second one, and this is f of x. And also for that an, we will have a formula like this: 1 by L into 0 to 2L f of x into cos n pi x by L. See that angle value has been changed here. Okay, so and then Bn value 1 by L into integral 0 to 2L f of x into sine n pi x by L into dx. So then and the corollary 1 where c equal to 0, c equal to minus L. The two intervals are changed here. One is 0 to 2L, another one is minus L to L. So in both the values, you will have the angle values as n pi x by L. So these are the things we have seen here up to that Bn value. So these are the basic things for the basic thing of the Fourier series. So here we'll stop it. Thank you.